Okay, so yeah, welcome everyone. This is the last tech talk of 2025 at Audacia, and it's with me, Luke Mitchell. It's about serverless architectures. Um, yeah, I'm Luke Mitchell, principal software engineer here at Audacia. I've been at Audacia for about 2 years now and worked on a varied amount of projects with them, which have all been, well, for the most part, been enjoyable anyway. Um, Today, what we're going to be covering is scalability, both horizontal and vertical. We'll just do a brief overview of those for those of you who maybe not don't know the difference or maybe have forgotten the difference between the two. We'll go through maintainability, fault tolerance, and performance, and just show how using serverless architectures you can encompass all these within your architecture quite easily and effortlessly. So yeah, scaling vertical versus horizontal. So vertical scaling is just where you have like one instance of a computer, and then in order to scale it, you have to increase components within it, basically. Add a new CPU, add some more RAM, add some more storage, etc. As opposed to horizontal scaling, where what you do is just add more of the same instance, which means that for horizontal scaling, it can become a lot more, well, it's fault tolerant by design because if one of the machines go down, you've also got other ones that are already there. Whereas in vertical scaling, because you've only got one instance or one machine, then obviously if that goes down, you don't have anything else to use to serve up your website or your API. So the first one that we're going to go over is actually the first project that I worked on. And this is to do with a function, grabbing a file from an SFTP server, um, going through that file and each entry, doing some work on that entry, and then putting it into a database in Snowflake. And what I quickly realized is like it wasn't very scalable in the sense of like it is vertical scaling as opposed to horizontal scaling because the way this function worked, it was only ever going to be one function, and it was actually just a continuously running function as well, which is a bit of a strange concept for me because I come from AWS, and in AWS, functions can only run for a maximum of 15 minutes, whereas in Azure, they can just run continuously, which means that instead of like a function, to me, they're more like a micro VM, micro virtual machine, which in this instance is probably not what you want anyway. I'm not sure, when you'd want that instead of like a full blown virtual machine anyway, to be something encompassed in your architecture. So with this, I decided that we could quite easily make this a lot more scalable, a lot more fault tolerant, just by a couple of little tweaks to the architecture. So we've still got the initial function, but what we've done now is added a storage queue, then added another function to process the data, to put it into the database. So what the initial function is doing now, instead of going through the file and doing the work on it that it needs to do to then add it to the database, it just splits each entry into an individual message and puts it onto the storage queue. Now, as soon as those messages go into the storage queue, what it'll invoke the second function, and that second function is actually going to scale up to multiple instances. So this is where your scalability comes in. So you're going to be doing like a lot of that in parallel now instead of just doing it one by one sequentially, which obviously makes it a lot quicker. And then in terms of like fault tolerance as well. So if your function stops at any point halfway through, what it'll do, it'll just let the message go back onto the queue, and then that message can get picked up again. Also, as well, if for any reason one of the messages can't be processed and then put into the database, what it'll do, it'll just put it onto what they call a poison queue, which is automatically created for a storage queue within Azure. So then you can see what's not being able to be processed, and you can do some, manual intervention there if you need be. Whereas on the first one, if we just go back a slide, if something wasn't able to be processed and it caused an exception, what you've done then is like you don't know how far you've got through that file, and then you're gonna have to obviously write quite a bit of like complex code in order to understand how to monitor that, and also be able to run through that file again to get all the data in there. Whereas with this one, it seems you just split it all up. Um, if you have anything that can't go in there, you know exactly what it is because it's just gone to your Poison queue and it doesn't affect the rest of the data anyway. It just all goes into the database and it's a blob storage. And then it makes the whole thing like effortlessly fault tolerant and effortlessly scalable as well in terms of how the function will scale with the amount of messages that go into the queue. Okay. So the next one we're going to go on to is a web server. So I've switched now from Azure into AWS, switching to the AWS because I'm a bit more comfortable with that, coming from an AWS background. Like I said, I've been working in Azure for like the past couple of years. So we'll just go over this architecture right now. So I have an internet gateway which just allows internet requests into your AWS VPC, which is a virtual private cloud. Uh, and then those requests can go into an application load balancer, which then can go into the EC2s, which are just virtual machines, which are just the orange hexagons there. And then the little the little symbol next to the application load balancer is just the auto scaling group. And what that does is, as there's more and more requests that come through, it can scale out and create more and more virtual machines for your web servers to be able to handle the requests that come through. And then also as well, as your requests go down, so it'll then reduce the amount of EC2 machines that you have as well in order to save you money. Because each EC2 machine, whether it's being used or it's not being used, you have to pay for it like minute by minute. It's just the way that it works with a virtual machine, and that's across like all cloud anyway, not just in AWS. So as you can see, I've split this into different availability zones as well, and what an availability zone is. So this would be a region within AWS, and each region normally has between like 3 and 5 availability zones. And what they are, they're just like physical locations where all your servers are at. And the reason why you want multiple availability zones is for availability because you've got things called scalability and availability. So basically, if an availability zone goes down for whatever reason, there's a power cut, something like that. Say if zone A went down, you can still serve your web server from zone B, and your auto scaling group can kick in and add extra EC2 machines if it needs to in order to put those in zone B. If you have like say, if you always want a minimum of 4 and zone A goes down, then your auto scaling group will kick in and put the other create another 2 EC2 machines in zone B. So you've got your minimum of 4 web servers there. So as you can see, there's quite a few moving parts with this. Obviously, if you're going to write this up or create this, you'd write it up in infrastructure as code, so then you could deploy it each time. And if you wanted to deploy it across multiple regions, it means it makes it a lot easier, or even like multiple environments as you're testing this as well. It makes it a lot easier to do that if you use it as infrastructure. We create it as infrastructure as code first. So how would we do this in a serverless manner? Well, it's actually a lot more simple than what it was before. So what we've got here is an S3 bucket, which is basically like blob storage in Azure. And all you do with this for we'll say this is like an SBS, a single page application, something like React or Vue, Angular, something like that. So you just put your files on the S3 bucket, and then you use CloudFront, which I think is it's front door in Azure, so the equivalent of front door in Azure. You use CloudFront to be the origin access, which basically means that all requests to your S3 bucket will go through CloudFront. And it also allows it to have HTTPS as well, because S3 on its own, you could serve a website from it, but you won't be able to go over HTTPS. You'd have to just go through HTTP. Um, but also with CloudFront, you get a huge amount of benefits because it's a CDN, it's a content distribution network, which means that it has a lot of like different edge locations. Um, so what I mean by that is, so I'll just switch back to the first one. So if you're gonna go, if you when you're going to your web server in the first instance of the infrastructure, each time you come to get a web page, you have to come to the region that it's stored in. So if this was stored in the London region, all requests are going to come through and have to hit the London region. Whereas on CloudFront, because it has something called edge locations, which are just like locations all around the world, what it does, it'll cache your files there. So then anytime a user comes to uh, to get to your website and they're not in the same region as you, so somewhere in Europe or in North America, if you've deployed this in London, in the London region, then it's served a lot closer. So therefore, it's going to be a lot quicker experience for your user to be able to get access to your website. Uh, in terms of scalability, it's kind of effortlessly scalable with S3 and CloudFront anyway. It's kind of just built in, and like availability as well. S3 is multi-AZ again, so multi-availability zone. So if an availability zone goes down where your files are stored, it can get them from another availability zone, and you don't have to worry about that because it's all just done behind the scenes for you. All you have to do is basically deploy your S3 bucket and deploy CloudFront, and then all like the caching and stuff like that is all there for you. So as you can see, it's like the management of this infrastructure is obviously a lot lower than the previous one, and it's also just a much more performant, especially being with CloudFront being a CDN where it's just made for serving up HTML, CSS, image files, which is what an SPA is basically made of when you're putting your files in S3. It's just going to be serving all those, and then from the edge locations when it caches them as well. So yeah, you get a huge amount of performance benefit from this, as well as maintainability and scalability as well. And then from that, you get your fault tolerance due to it being all multi availability zone by default. Uh, cool. So then the last one is exactly the same setup, but instead of being a web server now, we're going to say it's an API server. So again, yeah, obviously you created all this infrastructure, made it multi-availability zone, you obviously got your application load balancer there, etc., etc. So the way that I would do this in AWS as a serverless function would be using API gateway. Um, Now this looks a lot more complex than what it is. I put all these on here to show you what API gateway you can actually tap into in terms of resources that are available to it. Um, so if you haven't used API gateway, it's the same as APIM, API management in Azure. And if you haven't used either of those, it's basically a one-stop shop for hosting all your APIs within AWS or Azure. And from there, you can just combine all your performance and security and scalability and everything like that all in one place. And then what it allows you to do, it's just a gateway into your your AWS region to then be able to get into all your other services like Lambda, SNS, SQS, S3. So you can see like Lambda, you can there's an example there where you can get straight into DynamoDB, which is like Cosmos DB in Azure. So it's just a serverless NoSQL database. And then I've used that quite a lot for using like proof of concepts and stuff like that. It's just really quick to like get stuff off the ground. And again, it's all because it's all serverless. It's all like a pay-as-you-go model within AWS. Slightly different in Azure because you do have to pay for certain subscription models and stuff like that. Which is why I prefer AWS over Azure for running and deploying like serverless infrastructure. But Azure is still very good for it anyway. I won't say don't use it. I'm saying it's just a preference of mine. So in terms of using something like SNS as well, so this is the equivalent to that would be your service bus topic in Azure. And the great thing about that is it's got like the fan out architecture, which basically means you can because it's called what we call a pub sub, publish subscriber model. So the SNS publishes a message, and then you have like your various different subscribers, and you can have I've shown you there you've got a Lambda and a SQS, which SQS in terms of Azure would just be a message queue, which I showed on the first slide. Um, yeah, and what's great about that is it can just go to multiple different services, which then you can do whatever you want with it. On this example, I've shown that Lambda just like maybe sending to a Slack channel. Slack is the equivalent to Teams if you've not used Slack before, if you're just from like a Microsoft background. Um, and then SQS as well, it could go like to a queue, then to Lambda, and then maybe just throwing something like a SQL database. Or API gateway can just hook straight into SQS directly as well, which then can go to Lambda, or you can just hook it straight into S3 to store, obviously to stop files or anything like that, or retrieve files and things like that. I think like again, the good thing about this is it's multi-availability zone by default. You get all your scalability there. You get all your fault tolerance there as well. Because if anything goes down, you are able, it will, sorry, not able, it will just automatically sort all that out for you. Um, you don't have to mess around maintaining all that as well. And with it being serverless, you don't have to like patch your operating system that you're running on your virtual machines. You don't have to create images and update your images when you're patching your operating system or anything else like that. It's all just like managed for you. It makes getting off the ground a lot easier. Um, than it would do using a virtual machine. I think I guess it can be either or, like because obviously there's a learning curve to learning serverless architectures, but there's also a learning curve to like creating load balancers and auto scaling groups and maintaining virtual machines and stuff as well. So I guess it just depends what you invest in first, or whether what skills you've got in your team, which one you'd rather choose. But I would always like lean towards serverless architectures just because of how much they benefit you in terms of the four key things we've been speaking about, which is scalability, performance, um, fault tolerance, and I can't remember the last one. It's gone out of my head. But anyway, there you go. So that's me for that today, and I was just wondering if there are any questions around what we've gone through. Look now, Q&A. What's this then? One new change action with one function introduce a second one that interacts with queue. Downside, does this introduce more points to the process that could go wrong? Uh, okay, yeah, first one. So are we using so on the first one, let's just go, we'll click back to it, shall we? So there's a question around this one because I've added storage queuing into a function, basically introducing more points of failure and the process to go wrong. Yeah, potentially, but I think that the performance and fault tolerance benefits outweigh that massively in terms of what you got to do to introduce fault tolerance. Say when you don't have like the storage queue and it's just a function, like all the overhead of more code and maintainability there. I feel like making your architecture slightly more complex in this respect gives you a much better um, results in terms of like your performance, scalability, and fault tolerance. So I would always like lean towards doing this, even though at first it feels like why it's an overcomplication of what you're actually doing. Um, it's not really when you actually look at the benefits that it gives you. And then another one, do you think virtual machines will think will pass and everything will slowly move to service architectures? So, yeah, I guess, well, sort of. It depends because sometimes you do want virtual machines for certain things. I know that like most of the cloud providers are trying to push you towards serverless, but in terms of like sometimes you do want like long running processes and like even um, you might want server side rendering and stuff like that for your websites where you would need a server. Whereas unlike in this respect for S3, you can't do server side rendering because there's no server to render it on. You literally just it's just a file store and you're just serving up files. So I don't think it will completely be remove virtual machines. But I think for the most part, and for most use cases, serverless can definitely be more advantageous than using servers. But also as well, you got to think about when you're scaling up. At a certain point, serverless actually becomes more expensive than using virtual machines. But we're talking on scales of like Google and Facebook and stuff like that, like Netflix. But I guess for them, they'll probably have like the expertise of people being able to, manage the virtual machines and stuff like that and orchestrate all that kind of stuff to be able to manage it. But yeah, I'd say for the most part, serverless is probably the way forward. I think it's another question. Does hosting a site on CloudFront and S3 impact SEO? Yeah, so for those of you who don't know what SEO is, it's search engine optimization, and that just basically means how sorry, I'll just go to that one. Um, how visible your website is to a search engine, so like Google or Bing. So yeah, so if you just put the files into S3 and have CloudFront just serving them, it's quite poor for SEO. So what you want to do is do some sort of pre-rendering beforehand. And what I mean by pre-rendering is basically because what happens is when you serve a HTML file up to your browser, it renders it so then you can see something like the web page that you expect to see. So if you do that kind of pre-rendering and then put those files in the S3 bucket pre-rendered, it helps with search engine optimization. And you can also do something called static site generation as well. But I don't believe you can do that with when you want any dynamic content on there. What I mean by dynamic content is any content that you're going to get from like an API and stuff like that. So certain things, maybe like a homepage, you can have like as static site generation. But then anything else that you're going to be going and getting maybe some data from an API or whatever, you just do some pre-rendering on it and that to be able to then serve it up. And it would then be beneficial for SEO. Um, and then we've got another one. How do you handle cold starts in a production Lambda environment? Okay, so cold starts for anyone who doesn't know what cold starts are. So basically, when you've got a Lambda function or like a function in Azure, um, there is a certain time it needs to be able to obviously fire up to then process your request. Um, Once it's processed one request, and then obviously it continues to like process messages, you obviously it's already started at that point, so you can carry on using it. But yeah, that cold start for like the first request, you can normally say it can normally give you like a 1 or 2 second lag. Um, so what you can do in AWS is something called provisioning your lambdas. Um, so when you provision them, it basically means you've just got them constantly a certain amount constantly running, which you are having to pay for because you're doing it. So it just costs a little bit more. But then what that means if it is critical to obviously not have that cold start there in production, then they'll always be available there and always be able to like serve your requests as soon as they come in, and there won't be that lag phase there as well. Da, da, da. Another one here. What downside of serverless can you think of? For example, cold starts, we've gone through that, potential cost inefficiencies, etc. Yeah, like I say, I guess potential cost inefficiencies, that's just once it scales to a certain size, it can become more efficient in terms of costs. However, serverless, well, from an AWS point of view, anyway, is more efficient in terms of cost. just because it's on that pay-as-you-go um, subscription type model, and as opposed to with an EC2 machine or a virtual machine, you have to pay for that whether it's being used or not. So if they're just sat there doing nothing, you are still paying for them. Whereas like the architecture that you can see now, if no requests were coming in aside from the database because you're paying for the storage of database, but everything else there. It's just not you're just not paying for it until the request comes through. So in terms of the cost inefficiencies, it only kicks in really when you get to a bigger scale. Um, and then yeah, I think that's it for questions. Yeah, if there's no more questions. Think we can end it there. Thank you all very much for joining. Thank you all if you've joined over the past year as well to other Tech Talks. We look forward to seeing you in the new year.